The overall goal of this procedure is to create a bone template microenvironment that has the ability to restore missing or damaged bone. This is accomplished by first shaping and modifying a polyurethane sponge to fit within a defect area. The second step is to evenly coat the polyurethane sponge in a viscous hydroxyapatite slurry and allow it to dry. The final step is to sinter the hydroxyapatite coating in a high-temperature muffle furnace. Ultimately, a bone-like template with engineered microchannels is fabricated with high cell absorption and retention capabilities.
The main advantage of this technique over existing methods, such as solder retching or 3D printing techniques, is that the engineering of microchannels in the trabecula induces capillary action.
This method can help address major challenges in the field of regenerative medicine, such as the reconstruction of craniomaxillofacial and segmental bone defects.
The implications of this technique extend towards the therapy of congenital deformities. The templates are completely customizable in shape and size, and the capillary action will encourage long-distance cell migration.
Though this method provides insight into regeneration of bone, it can also be applied to the other culture systems such as the 3D cancer culture platform.
Begin by trimming polyurethane sponges with 80 pores per inch into bridge shapes with dimensions of 3.5 centimeters in height by 5 centimeters in width by 1.5 centimeters in depth. Next, make 100 milliliters of a 4% sodium hydroxide solution using a 150 milliliter beaker. Immerse the sponges in the sodium hydroxide solution and squeeze out the trapped air until the sponges are completely soaked.